Next, we are going to learn on concavity. Concavity describes whether the curve is cupped up or cupped down, or in other words, whether the curve is concave upward or concave downward. To determine the concavity, you need to identify f prime x and f double prime x first. Next, find the value x equal to c when f double prime x equal to 0. If f double prime is less than 0 or negative, then the function is said to be concave downward on the given interval AB. But if f double prime is greater than 0 or positive, then the function is said to be concave upward. Refer to example 7. You need to determine the interval on which the function is concave upward or concave downward. To solve, you need to differentiate the given function with respect to x first. You should get f prime x equal to 2x to the power of negative 1 over 3. Differentiate once again, you should get f double prime x equal to negative 2 over 3 x to the power of negative 4 over 3. By letting f double prime x equal to 0, you will obtain x equal to 0. By taking x equal to 0 as the cutting point, you will obtain two intervals which are negative infinity to 0 and 0 to infinity. Then, for the sign of f double prime, by taking any value within the interval, you will get negative from 0 to the left and negative from 0 to the right. As both interval having negative sign, therefore we can conclude that both interval negative infinity to 0 and 0 to infinity are concave downward. Refer to example 8. You need to determine the interval on which the function is concave upward and concave downward. To solve, you need to differentiate the given function with respect to x, and you should get f prime x equal to 4x to the power of 3 minus 12x squared plus 10. Differentiate once again, you should get f double prime x equal to 12x squared minus 24x. By letting f double prime x equal to 0, you should obtain two x values, which are 0 and 2. By taking these two x values as the cutting point, you should obtain three intervals, which are negative infinity to 0, 0 to 2, and 2 to infinity. Next, check the sign of f double prime x. Substitute any value within the interval into f double prime x. You should get positive sign from negative infinity to 0, negative sign from 0 to 2, and positive sign from 2 to infinity. Therefore, we can conclude that the function is concave upward on the interval negative infinity to 0 and 2 to infinity, and it is concave downward on the interval 0 to. The last section of the lesson today is on inflection point. A function may change concavity at one or more points. Such points are what we call as inflection points. To determine the inflection point, first of all, you need to identify f prime x and f double prime x. Next, find the value of x equal to c when f double prime x equal to 0. And substitute x equal to c into the fx to obtain the inflection points. Let's refer to example 9. You need to determine the inflection points for the function in example 7 and 8. From example 7, there is no changes of concavity at point x equal to 0. Therefore, we can conclude that there is no inflection points for this function. As for example 8, the concavity change at 2 points, which are x equal to 0 and x equal to 2. Substitute these two x values into the fx, you should get two inflection points which are 0, 0 and 2, 4. Following are the general characteristics of the function f according to sign of f prime and f double prime.